Hey everyone, and welcome to the Null channel. Are we ready to learn a little bit more about databases? Now, I know that I haven't done a whole lot of these on databases, but we're getting excited about databases and how databases work. So, if you're unfamiliar with this series, just a quick warning, these videos are fairly technical and they tend to build on top of each other. If you're just starting or find yourself confused, go back and watch the other videos in the series. Also, go ahead and join the Discord and ask your questions in the comments below, or if you have any ideas on this, go ahead and let me know. So I know the last video I told you that we needed to figure out some way to actually delete values from our database. Well, we have a way to mark them as deleted and the database pretends that they're gone. We don't actually delete it from the log. Not only that, updating a value also does not delete the old record and just writes a new value. This is kind of a problem. My computer is running out of space. But it turns out that our database, in its current form, cannot do this without becoming the absolute slowest database on Earth. And that's kind of a problem. Everything is in one big flat file. If we do go and delete these logs, we would end up locking the entire file with an exclusive lock. This would have a huge impact on performance, as an exclusive lock would mean that nothing else could operate on that file. We could not make any other reads. In general, our goal is to avoid ever, and I mean never, ever pausing writes. The issue is compounded by the fact that we don't have an index yet. And I know, but we are going to ignore the index for a while. Trust me, while it lets us optimize finding crap and would really let us delete something from the file faster, it does not solve the issue, as we would still need to lock the file, causing us to pause reading and writing on a whole file. Again, as far as I can help it, I would want to avoid locking as much as I can. It's expensive, and if you exclusively lock a large file like this, it can be very, very slow. Now, before we do this, before we can work on fixing this egregious issue with our database's inability to delete stuff from disk, we're going to have to do something else to enable us to not lock writing and reading while still cleaning up these values. And the fact is, we made a huge architectural mistake in our very first video. But it's okay, we actually meant to, because we're taking this one little chunk at a time. There is no real way to do it with how the file is structured right now. Right now, we just have this one really big file, and there is nothing we can do with it. No trick that I know of to delete things without using an expensive exclusive lock. Well, I mean, I guess the only way that avoids corrupted data, because we could just not have the exclusive lock and corrupt our data. Two things I don't really want to do: pausing reading and writing and corrupting our data. People seem to get overly upset about you corrupting their data in your database. It's weird. I don't know what it is about it. What we're going to do in this one is take our log-based database and make a log segment database. We're going to take our single file and make our database work using a bunch of small immutable files. The immutable part is important, but we're going to talk more about that in just a little bit. The order inside our file is important, as only the newest record is the correct record. So keeping track of the relative age of a record in file A versus file B is very important. This is a requirement that we keep things in order, or we would not know what the newest record is, or if the record is even deleted. This is where timestamps are going to come in. For now, at least, each file is going to get a timestamp of when it gets created. So when we are looking for a record, we can start with the newest file and work our way backwards through the file. Really, we are just dealing with these individual files like we would with the records inside of the file. We're looking for the newest ones first and going backwards through them. This is not how we're always going to keep track of this, and the indexes will enable us to do some of these things much differently, but one little step at a time. Another thing we're going to have to think about is the fact that we are going to need to create a file size limit and maybe make it configurable, because, people like to configure their database. Right now, for today, we are going to create that simply based off the numbers of records currently in the file, not the size in memory or disk. Later, we will update this to be the same size represented on disk when we have a little better definition of what a record is and how much space on disk it might take. Now that we've talked about the general theory, and it's really quite simple. Let's talk about a rule around these new log segment files we're going to have to be using as we do this. We're going to say that these segments are read-only, meaning the only file to ever be written to is the main log file. Everything else is read-only and immutable. I know that does not seem like it would work because we really wanted to delete stuff from them, but don't worry. Don't worry, I got you. I wouldn't lead you down a bad path, would I? We're gonna get to that. Just remember, immutable does not mean the file itself cannot be deleted. It just means we won't be changing the contents of the file itself. If you're liking this and want to see how we eventually end up able to efficiently delete things from our log-based database, a process we're going to call compaction, then stick around and make sure you're subscribed and hit that bell for updates. I'm not going to get into log compaction right now in this episode as I'm trying to keep these videos in as short little bites as possible, but compaction is going to empower us to actually delete things from our database in a way that doesn't require locking or even searching the database. That's right, we don't even have to search the database. Log compaction is actually pretty cool, but we'll have to get in our database ready to be compacted. I promise that the next episode on this database will be log compaction, and it will be fairly soon because I have already written the code for it. Another quick note here, all immutable log segments have the file extension null segment, while the main writable log is called null.database. This will be the only writable file. All the other files, once written, are done, dusted, and finished, never to be updated again. But why this is important? Why is it so important that they are read-only? Is it important? Especially the read-only part? Let's think about that for just a second. If these files are read-only, it means that we can freely read any of them without locks. Yeah, no locks. Because reading from multiple threads and even multiple processes will not corrupt your data. Also, the write lock is only going to lock the main file, meaning that once the read locks have dropped from it and those threads have moved on to the immutable files, we can start writing maybe before the reads are even done. It's a win-win. But how does this help with deleting? Well, let me know in the comments if you have any ideas, but again, we'll be covering that very shortly in the near future. Now that we have a general idea of what we want to do, let's jump into the code and bust this out quickly and simply. We are writing in Rust after all, so we know that it's notoriously simple. If you're not familiar with Rust, please don't fret. I try to keep the code simple and easy and updated. Now, I just sat down to live write this out and record it, and I realized that actually is going to be a lot of code, and I'm not sure that that is the best way to show it. So what I'm going to do is we're going to just write a lot of the code, and then we're going to go through and talk about what we did. If you guys would rather see this live written, we can do that. It will extend the videos out. So just let me know what you want in the comments. I just want to try to get the points across and show you guys the code. All right, so here we are with the put value for key. Now, this one was quite fun because I found out that we had a little bit of bad programming, and I went through and fixed that. If you'll notice here, this is really simple now. And what the bad programming was that delete was actually the exact same, but we were just writing a very specific file. So now I have this function called write value to log, which writes a value to log. And here you can see that we're just concatenating the key and body like we normally do and passing that into this. And now this function has all of the stuff in it to write a value to a log. This is really, really cool and now saves us a lot of time. And this is really clean to read. You can see now all we do is we get the write lock, which you should do, and we write to a log. And then we send back an okay response if it worked and a failure response if it didn't work. Super cool. Now let's jump into the write log to understand that a little bit better. All right, so here's our logic for writing to our log now. First, we're going to get the line count for the file. As you can see, that's what we're doing right here. If our line count is more than 64, we're gonna have to create a new file. And what we do is we copy the old database to a new file that has the timestamp and the log segment text. This is just a constant that we have of null segment. And so this is going to write that file out for us and make a new log segment. After we write that new log segment, The only thing that we have to do next is then just open the same database file, the writable one, with truncate on. And we now have a clean file to start adding new records to. At this point, all we have to do is write our line, and if it fails to write, we return an error, and if it doesn't, we return OK. Now, that is if our line count is above 64. If it's not above 64, we just do what we were always doing in the last episode. We just open the file and write a new line. That's it. It's as simple as it is, and this is the end of this function. It's really simple, and it's not too bad. Now, let's jump into the delete just so that we can see it is the exact same thing as the put. So we have put value for key. Here our delete value is, but you can see we're passing this constant, this tombstone constant, that puts this for the value. That's how our database knows that the record has been deleted. So let's go ahead and update our get value, because now we need to expand it out to understand the multi-file record, because right now it just looks off the main log. Now you're going to see some more improvements even in this, and we'll talk about how these came about. They were just really nice and helpful, allowed us to break out some functionality that maybe will go into their own files eventually. First thing here, we got a read lock, just like we normally did. And you know what? Really, we have to do the exact same thing. We have to first start with the null database file. Now, interesting thing here, I actually have a way, and it will be the next video after the log compaction, of how we never actually have to read from this file. That's right. We don't actually have to read from this file, meaning we'll never have to read lock it, which means it will only ever write lock. Really, actually quite cool. But that's not today. Today, we're worried about breaking this up into logs. So the first thing we have to do is make it read from multiple files, but we have to read this file first. So we're going to do it. The first thing you're going to notice that is different here is we have this cool new function called check file for key. If you go and actually look at this definition here, it just does what we were doing. It takes a file and a string, and it returns the value or an error. Now, this was actually pretty cool. I made an error enum for this because there's actually a couple different types of error, and it's important. It's very important to know which error you're having. We have value not found and value deleted, two different errors. They're not really errors, but this is how I'm returning them in the result. There's also the IO error, which wraps the IO error. So you can actually have the error that you couldn't open the file. You have the error that the value was deleted, which you can't return that as an empty value. It's very, very specific and very important. And you have the value that it wasn't found. So that's this file, and this allows us to clean up the other code because we're actually going to have to use this file twice. So now, looking for a key is as simple as check key for file. And we can use the super powerful match that Rust gives us. And all we can do is basically, if we find the value, we return it. If we don't find the value and it was deleted, we return that the value wasn't found. And everything else just means we continue on and check all the other files. Super cool, super cool. All right, so if we don't find it, this is where we have to go and check all the other log segments. Let's look here at this here. I made this. It just gets all of the files in a directory. Super simple function. You can check it out yourself. And basically, it just filters it to the log segment extension. So it's going to just get files of log segments. So this will give all of our log segments. And then down here, I sort them because remember, we timestamped them. Now we could do this with file metadata, but you know what? I was being lazy and just put the name as the timestamp because it was super simple. In the future, we're going to update this, but again, we take baby steps. So we sort them by their names, which is super easy. Unstable sort, if you don't understand what that is, it does mean that it could reorder same values, but we don't care. We shouldn't have same values. That would be a bug. So it doesn't matter to us. All right. So then all we're going to do is iterate over these with a while loop. But this while loop is so easy because we made this function, check file for key, that's just going to do it. And this is almost the exact same as the last one. Cool. All right. And if we don't find it in this while loop, then we just return not found. I'm torn here, honestly, whether we return an OK or a 404. The request was OK. The value wasn't found, but this isn't a REST value. So I feel like OK is the correct, but I think maybe 404 is the correct version. I'll probably change it when I push this code. I'll probably change it. And that's it. We're done. That was as easy as it was. We have a database up and running now. Let's go ahead and run this. All you have to do, again, is cargo run. It's going to compile it out really quickly and really simply for you. And now our database is running. We can add and remove values to our heart's content. It's really, really awesome. And that's it. Now we have all of these log segments out there. And if you keep adding, and if you use the benchmark tools to add kind of quickly a lot of values, you can see a bunch of files are created and all of them have 64 lines in them. This is cool. We are now done with our log segments, right? Kind of. I mean, what did we really accomplish? Well, now we have these log segments. And guess what? We can read these log segments without fear. We will never write to them ever. These are for reading only. It's fantastic. It means we don't even have to read lock them anymore. It's a small overhead, but it's one that I'm happy to shed. Now, did we do compression like I had promised last episode? Absolutely not. I lied. It turns out you can't trust people on the internet. And it also turns out that I could not fit log compression into this video and keep this video to a timely length. Was this even short? Well, kind of, but not really. Hopefully this is a nice little bite of information you can take and learn from. Some of these videos are going to be really complicated, and I want to try and break them down as small and short as possible, meaning that we're not always going to make these huge strides in progress, as we're going to have to do little things to keep moving forward. This way you can watch as many or as few as you need, letting you stop watching when your brain starts hurting. But let's be honest, I explained everything so well that your brain hurting will never happen. But let me know what you think in the comments. But don't worry, some of these are going to be very long videos. Because, well, to be honest, sometimes I'm just not smart enough to break down parts into smaller parts. Like the log segments, I've already written that code and it's going to be a long video just to cover it in enough detail to not confuse you. But I'm going to try my hardest to break them down into small pieces possible. Please let me know if you have any questions in the comments, and I'll try to answer them as quickly as possible. And as usual, if you did not find these videos useful and hate learning how to store data reliably while supporting quick and reliable access, go ahead and hit that subscribe button, stick around, and prove in the comments that you know better.